This is the exam review for the Honors Geometry semester exam for Unit 2, Topic 2. I wanted to draw your attention to the formula sheet given on the front of the review packet. This will be given to you on the exam, and this is the topic that predominantly uses the formula sheet. So we've got Pythagorean's theorem, which is used in Unit 2, Topic 1 as well, but it's going to be used a lot in the trig unit. And additionally, we're being told what our sine, cosine, and tangent ratios are. We're also given the law of sines, the law of cosines, and we're given the formula for the area of a triangle when it's not a right triangle. So please remember that these are the formulas you're going to need, and these are the ones that are going to be given to you, so you don't need to worry about memorizing them. You just need to know how to use them. So question 53 says, given right triangle ABC, so that's right here, ABC, use the item bank to identify the following. Items may be used more than once. All right, first thing we have is the leg opposite angle A. So opposite is always across, so that's going to be BC. The leg opposite angle C is going to be AB. The sine ratio of angle A. Well, if you can't remember, there's a mnemonic device, SOHCAHTOA. SOHCAHTOA tells us our trig ratios. So we've got sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So our sine ratio of angle A is going to be opposite over hypotenuse, which means we're going to have BC over AC. Cosine ratio of angle A is adjacent over the hypotenuse. So in this case with angle A, adjacent is going to be AB over a hypotenuse of AC. Next is our tangent ratio. Tangent means opposite over adjacent. So from angle A, our opposite is BC and our adjacent is AB. Moving down, we've got the sine ratio of C. Again, sine is opposite over hypotenuse, but now we're looking from angle C. So our opposite is going to be AB, and our hypotenuse is AC. I know I cut off the diagram up at the top, but you have yours on your paper to help you. Cosine ratio of C, that is adjacent over the hypotenuse. So our adjacent is BC over a hypotenuse of AC. Our tangent ratio of angle C is opposite over adjacent. So from angle C, our opposite is AB over our adjacent of BC. So AB over BC. Next, we're being asked the angle whose sine ratio is BC over AC. So with sine, we know we're talking about opposite over hypotenuse. So which angle has an opposite of BC and a hypotenuse of AC? Well, this opposite means angle A. So our answer is going to be angle A. J is the angle whose tangent ratio is AB over BC. Tangent is opposite over adjacent. So we're looking at which angle has an opposite that's AB and an adjacent that's BC, and that would be angle C. Finally, our hypotenuse, and our hypotenuse is always the side opposite the right angle, which is AC. Question 54 says, let ABC be a right triangle with the right angle at C. So we're going to have a right angle right there. Which statements are true? Check all that apply. So the first one is angle A and angle B are complementary. Remember, complementary, the way I like to remember it is the right thing to do to complement someone. So right angle complementary means angles add up to 90 degrees. Well, if this angle is 90 degrees and 180 degrees are in a triangle, 180 minus 90 is 90. So the sum of A and B must add up to 90 degrees. Therefore, this is true. Measure of angle A equals 90 degrees minus the measure of angle B. Well, if the measure of angle A plus the measure of angle B adds up to 90 degrees, then the measure of angle A must be 90 minus the measure of angle B. So this one is true as well. Tangent of A equals sine of A over cosine of A. Let's first find out what tangent of A is. So we're looking from this angle right here. Tangent is opposite over adjacent. So it's going to be equal to BC over AC. Sine of A is opposite, which is BC, over hypotenuse, which is AB. And cosine of A is equal to adjacent, which is AC, over hypotenuse, which is AB. We're looking to see if tangent A equals sine of A over cosine of A. Sine of A over cosine of A is the same thing as sine of A divided by cosine of A. So we're going to be looking at BC divided by AB and what that divided by AC over AB looks like. When we divide fractions, we keep the first fraction the same and we multiply by the reciprocal of the second fraction. What I can see is that I have AB in the numerator and the denominator, so they cancel out, and I'm left with BC over AC. So if tangent of A is BC over AC and sine of A over cosine of A is BC over AC, then this statement is true. The fourth one is AB squared equals AC squared plus BC squared. This is just Pythagorean's theorem, so that is true. Next one is sine of A equals cosine of B. Well, we already found sine of A, which is BC over AB. So let's find cosine of B. Cosine of B is from this angle right here, and it's adjacent over hypotenuse. So it's going to be equal to BC over AB. And we can visually see that sine of A is equal to cosine of B. So this works. The next one is cosine of A equals sine of 90 degrees minus A. First of all, if we know that these two angles are complementary, we know that they add up to 90 degrees. So if I take 90 and subtract angle A, I'm going to get the measure of angle B. It's kind of this, but solving for B instead of A. So I know that this is going to be sine of angle B. We know cosine of A is AC over AB. So now we just need to find what sine of B is. So sine is opposite over hypotenuse from this angle. So AC over AB. So therefore we have cosine of A, which is AC over AB, equals sine of B, which is AC over AB. That is a true statement, so we're going to check mark it. The last one says if angle A is congruent to angle B, so if this angle is congruent to this angle, then the measure of angle A equals 45 degrees. Well, if X plus y equals 90 degrees, because we know they're complementary. And basically, one equals the other, so x plus x equals 90 degrees. We've got 2x equals 90, divide by 2, we get x equals 45. So this is also a true statement. They are all true. Question number 55 says, look at the two triangles below. We've got a right angle, a leg of 16 and a leg of 12. We've got a right angle with a leg of 16 and a leg of 12, and they both have an hypotenuse of 20. Sandra says that since the two triangles are congruent, she believes that sine A equals sine B. Is Sandra correct? Justify your answer. Well, one of the things that we're going to look at is what is sine of A and what is sine of B. We know sine of A, here's angle A, is opposite, which is 12, over the hypotenuse, which is 20. Sine of B is opposite, which is 16, over hypotenuse, which is 20. So we can very clearly see that 12 over 20 does not equal 16 over 20. Therefore, Sandra is not correct. To justify, we're going to put some words in. So, although the two triangles are congruent, we know that sine of A does not equal sine of B because sine of A equals 12 over 20, sine of B equals 16 over 20, and 12 over 20 does not equal 16 over 20. Therefore, Sandra is not correct. Question 56 says, look at the figure below and note that it is not drawn to scale. Show that the value of cosine of S is the same if triangle SQU, so the big triangle, or triangle SRT, the small triangle, is used. So the first thing we're going to do is let's find the value of cosine of S if we use triangle SQU. So SQU is the big triangle, and we're looking at angle S right here. So cosine means adjacent over hypotenuse. So we're going to have to add up the two lengths on this side and the two lengths on the hypotenuse. So the cosine of S is going to be 12 plus 8 over 15 plus 10. 12 plus 8 is 20. 15 plus 10 is 25. And this simplifies to 4/5. Now if we look at triangle SRT, we're still going to be finding cosine of S, but we're going to be looking at this small triangle. So S is right here, cosine is adjacent over hypotenuse. So this is going to be 8 over 10, which simplifies to 4/5. And therefore we've shown that the cosine of S is 4/5, whether you use the small triangle or the big triangle. The next question asks us, what is the value of sine of U? Well, sine of U is right here. Sorry, angle U is right there. Sine of U means opposite over hypotenuse. And our opposite is going to be 12 plus 8. So this entire length is the opposite of this angle over my hypotenuse, which is this entire length. So 12 over 8 plus 15 plus 10. 12 plus 8 is 20. 15 plus 10 is 25. And this simplifies to 4/5. Finally, we are asked, is cosine of u equal to cosine of t? Why or why not? So let's first find cosine of u, which means adjacent over hypotenuse. So cosine of u, my adjacent is 15 over my hypotenuse of 15 plus 10. This gives me 15 over 25, which simplifies to 3/5. Then we have cosine of t. Again, it's still adjacent over hypotenuse, but we're looking at this angle. So my adjacent is going to be 6, my hypotenuse is 10. So this is going to be 6 over 10, which again simplifies to 3/5. Therefore, we know cosine of u equals cosine of t because they both equal 3/5. Question 57 says a skateboarder has a piece of plywood that she wants to use as a ramp. The plywood is 16 feet long, and she wants to put a vertical support under the ramp so that the ramp is at a 20-degree angle to the ground. This is shown in the figure below. The view is from the side of the ramp. The question is, how high is the vertical support? Round your answer to the nearest hundredth of a foot. So first of all, I want to underline this because it's really important that if it asks you to round to a certain number, that you actually do. So we know that we've got an angle of 20 degrees, and we need to find our vertical support, which is opposite the 20 degrees. We already know the hypotenuse, so this tells us that we're going to use the sine function. And sine of 20 degrees is going to equal the opposite, which is the vertical support, over the 16-foot ramp. So this is my opposite side, vertical support, over my hypotenuse, which is my ramp. I'll use x, or I can use x to represent vertical support, but I know that I need to get the vertical support by itself. So if I have division right here, to get rid of that, we multiply both sides by the denominator. Therefore, we know 16 times sine of 20 degrees is going to equal our vertical support. And then I'm going to use my calculator, and I'm going to make sure that it's in degree mode, not radians. Otherwise, this completely changes your answer. But I'm going to type in 16 times sine of 20, and that's going to give me approximately 5.47 feet. Round correctly because you're rounding to the nearest hundredth. Question 58 says, Josh has a 17-foot ladder. He would like to place the ladder against the side of a vertical wall so that the top of the ladder is 15 feet up the wall. So basically what we have is a picture like this. Josh has a 17-foot ladder, and he wants to place it up against the side of a vertical wall so that it's 15 feet up the wall. Safety guidelines state that the angle that the ladder makes with the horizontal can be no more than 70 degrees. So we're talking about this angle right here. Can Josh safely place the ladder against the wall? So basically what we need to find is, what is the measure of this angle, and is it more or less than 70 degrees? Well, I see that from this angle, I have an opposite and I have a hypotenuse. So I'm going to use the sine function, and I'm going to have sine of theta equals 15 feet over 17 feet. In order to solve for theta, I have to get it by itself. And the only way to do that is to use the inverse function. So the inverse function says that I'm going to take sine, and it's like a -1 exponent of sine of theta. And what I do on one side, I have to do on the other. So I'm going to take the inverse sine of 15 over 17. Well, the inverse sine of sine of theta just gives us theta. So theta is going to equal the inverse sine of 15 over 17. We can use our calculator. The inverse sine is when you press second sine on your calculator. And we're going to get theta is approximately 61.928 degrees. So yes, Josh can safely place the ladder against the wall because the angle is 61.928 degrees, which is less than 70 degrees. Part B says, suppose that Josh wanted the top of the ladder to be 24 feet up the wall. So let's say we had our picture, but instead we want this to be 24 feet. In order to meet the safety guidelines, what is the minimum length of ladder that Josh needs? Round your answer to the nearest hundredth of a foot. Well, we know minimum guidelines says that this angle has to be no more than 70 degrees. And we want to know how many feet can this ladder be? Well, again, I'm given this angle and I'm given an opposite and a hypotenuse. So I'm going to use the sine function, but this time I'm going to have sine of 70 degrees equals opposite, which is 24 feet, over my hypotenuse, which is x feet. So I need to solve for x and get x by itself, but right now x is in the denominator. So the only way to get rid of something that's in the denominator is to multiply both sides by that value. So I'm going to have x times sine of 70 degrees equals 24. Now to get x by itself, I can divide both sides by 70 degrees. So what I'm going to get is x is going to equal 24 over sine of 70 degrees feet. And when I round that, I get approximately 25.54 feet. So the minimum length of ladder that Josh needs is 25.54 feet. Question 59. A plane takes off from a runway and climbs at an angle of elevation of 15 degrees. So we have a plane taking off and is climbing at an elevation of 15 degrees. Part A says after the plane has traveled 1 mile, 5,280 feet, so this plane has traveled 5,280 feet. How far has the plane traveled horizontally? So we want to know how far is this value. Round your answer to the nearest foot. Well, I'm given an angle, and I can see that I'm given the adjacent and the hypotenuse. So I'm going to use cosine, and cosine of 15 is going to equal x feet over 5,280 feet. To get rid of the denominator, I'm going to multiply both sides by 5,280. And I'm going to get that x equals 5,280 times cosine of 15 degrees. When I put that in my calculator, I'm going to get approximately 5,100 feet, rounded to the nearest foot. In part B, it says after the plane has traveled 1 mile, so again, we're traveled 5,280 feet. How far has the plane traveled vertically? So in this case, we still know it's going at 15 degrees, but we want to know how tall this is. So I'm given an angle, and I'm given an opposite and a hypotenuse. So this time I'm going to use the sine function, and sine of 15 is going to equal the opposite over my hypotenuse of 5,280 feet. And to get rid of the denominator, I'm going to multiply both sides by 5,280. This is going to give me x equals 5,280 sine of 15 degrees. And like the directions say, I'm rounding to the nearest foot. So x is going to be approximately 1,367 feet. Question 60. A farmer wishes to make separate sections of a piece of land as shown in the figure below. All triangles are right triangles. So that means that we know that this is also going to be a right triangle. Part A asks, what is the value of x? Well, we see that we need to know x, which is the hypotenuse of this triangle. So we can use Pythagorean's theorem. So we're going to do a squared plus b squared equals c squared. So a squared is 15 squared plus 20 squared equals x squared. 15 squared is 225, 20 squared is 400, and together they add up to 625. We need to square root both sides, so we know that 25 equals x. So the value of x is 25 meters. Don't forget the units. Part B asks, what is the value of y? Well, now we know what x is, we want to find y, and we know what the hypotenuse of this triangle is. So we're going to use Pythagorean's theorem again. A squared plus b squared equals c squared. This time, we're going to plug in 25 squared plus y squared equals 65 squared. 25 squared is 625 plus y squared equals 65 squared, which is 4,225. I'm going to subtract 625 on both sides and get y squared equals 3,600. And when I square root both sides, I get y equals 60. And in this case, y equals 60 meters. So we know y equals 60 meters. We know x equals 25 meters. The last question asks us, what is the area of the trapezoid? So in order to find this, we need to break this into 3 sections, 3 triangles. We're going to find the area of triangle 1, the area of triangle 2, and the area of triangle 3. Let's start with triangle 1. We can see that the area is 1/2 base times height, because that's how we find the area of a triangle. It's going to be 1/2 base, which is 15 meters, times my height, which is 20 meters. And when I multiply this all together, I get 150 meters squared. When I do triangle 2, I also know area equals 1/2 base times height. So this is going to be 1/2, 25 meters, times my height of 60 meters. And when I multiply this all together, I'm going to get 750 meters squared. Sorry. Finally, I need to find the area of number 3. But I'm missing some key facts. I'm missing the base and I'm missing the height. So I need to find the height of the triangle, the base of the triangle, or vice versa, it doesn't actually matter. And then I can do area equals 1/2 base times height. In order to find the base and the height, we're going to need to use trig, and we're going to need to find this angle. And in order to find that angle, we need to find this angle first. So I'm going to label this angle 1 and angle 2. So let's start with angle 1. I know my opposite side and I know my adjacent side. So I could use trig and say the tangent of angle 1 is going to equal 20 over 15. In order to isolate angle 1, I need to do the inverse tangent. So I'm going to do the inverse tangent of angle 1 is going to equal the inverse tangent of 20 over 15. So this is going to give me the measure of angle 1, which equals the inverse tangent of 20 over 15, and that is going to be approximately 53.13 degrees. So if angle 1 is 53.13 degrees, that's right here, and we know this angle is 90 degrees, we can solve for the measure of angle 2. The measure of angle 2 is going to be 180 degrees minus 90 degrees minus 53.13 degrees. So the measure of angle 2 is going to be approximately 36.8699 degrees. Since I now know this angle measure, I can use trig to find my height and my base. Let's start with my height. If I know this angle measure and I know the hypotenuse, I can use sine opposite over hypotenuse to get my answer. So the sine of angle 2 is going to be h over 60 meters. So the sine of 8699 degrees equals h over 60. I'm going to multiply both sides by 60, and I'm going to get h equals 60 times sine of 36.8699. Therefore, h is going to be about 36 meters when you put it in your calculator. Again, I want to always remind you, make sure that your calculator is in degree mode. So we found h. This is 36 meters. And now we need to find the base. Well, since the base is this side, and I know this angle measure, I need adjacent over hypotenuse, which means I'm going to find the cosine of angle 2, which is going to be the base over 60. So we know that this is going to be cosine of 36.8699 is going to be equal to b over 60. I'm going to multiply both sides by 60 and get b equals 60 cosine of 36.8699, and therefore b is going to be approximately 48 meters. So going back to my original find the area of section 3, the area is going to be 1/2 base, which is 48 meters, times my height of 36 meters. And this is going to give me an area of approximately, so I actually should put my approximate signs since these are rounded, of 864 meters squared. So my final question is, what is the area of the trapezoid? So I need to add my three areas together. So my area is going to be 150 meters squared plus 750 meters squared plus 864 meters squared. And that's going to get me approximately, since these are rounded, or the last one, 864 is rounded, approximately 1,764 meters squared. So I know there's a lot of work on here, but this is a complicated and multi-step problem. But hopefully you can follow along and understand how we get the answers. Question 61. A swimmer tries to swim straight across a stream. The stream is 100 feet wide, so our stream is 100 feet wide, and there's a current in the stream that's perpendicular to his intended path, and it caused him to land 20 feet downstream from his intended landing point. So basically, this is the actual path that he traveled. The question is, how far did he swim? So we want to find the length of the actual path and give your answer to the nearest tenth of a foot. Well, since I have a right triangle and I know the length of the two legs, I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. A squared is going to be 100 squared, b squared is 20 squared, and my actual path is c squared. So I'm going to find that. 100 squared is 10,000, 20 squared is 400, and when you add them together, you get 10,400, which equals c squared. In order to solve this, I need to square root both sides. I know I'm going to be using the positive value because it's a length. So c is going to be approximately 102.0 feet. Because it asks you to round to the nearest tenth, you do need to include that 0.0. So he swam about 102.0 feet. Part B says, at what angle theta was his actual path to the intended path? Give your answer to the nearest tenth of a degree. Well, we're looking for what theta is, and all we know is for certain is our opposite and our adjacent. Now, I understand that you just found the actual path, but I don't recommend that you use that. I don't recommend that you use sine or cosine, because if you got this answer wrong, you're going to get part B wrong as well. But if we use tangent, we already know those values, and this gives us a different opportunity to get the problem right, even if we got part A wrong. So the tangent of theta, that's opposite, which is 20 feet, over adjacent, which is 100 feet. So in order to find theta and get it by itself, I have to take the inverse of this function. So I'm going to take the inverse tangent of theta, and what I do on one side, I have to do on the other. Inverse of tangent and tangent of theta right here, they cancel out. I'm just left with theta, and theta is going to equal the inverse tangent of 20 over 100. I'm going to use my calculator. The inverse tangent button is second tangent, and what we're going to get is theta equals, I should say, is approximately 11.3 degrees. And so the angle of his actual path to the intended path was 11.3 degrees. Question 62 says Kevin purchased 2 farms. So he purchased here and here. Currently, the 2 farms are connected by 2 roads. Kevin wants to construct a new road connecting the 2 farms directly. The figure below represents the situation. Part A asks, what will be the length of the new road? Your answer should be correct to the nearest hundredth of a mile. Well, as we notice when we look at this diagram, we have 2 lengths. We need to find this length, and we're given an angle measure, but it's 68 degrees. It's not a right triangle, so we can't use Pythagorean's theorem, and therefore we're going to have to use either law of sines or law of cosines based on what we know. Law of sines is a ratio, and I would need to, if I was finding a missing angle, I would need to know 2 sides and 1 angle. But unfortunately, I'm looking for a missing side, so I would need to know another angle, and I don't have that. So I'm going to have to use the law of cosines. Remember that I'm looking for the nearest hundredth of a mile. So we're going to use the law of cosines. And I'm going to assign my triangle as A, B, and C, meaning that across from angle A, this is going to be a lowercase a. across from B is going to be a lowercase b, and across from C is the lowercase c. So I am looking for the new road, I'm looking for C. Law of cosines says c squared equals a squared plus b squared minus 2ab cosine of c. Again, you're given this formula on the beginning in the front of your book, so you don't need to memorize it. I don't know what c is, that's what I'm trying to find. But I do know a is 23, so it's going to be 23 squared plus 14 squared minus 2 times a, which is 23, b, which is 14, and cosine of angle C, which we know is 68 degrees. So c squared is going to equal 23 squared, which is 529, plus 14 squared, which is 196, minus 2 times 23 times 14, which is 644, cosine of 68 degrees. C squared equals 529 plus 196, which is 725, minus 644, cosine of 68 degrees. So when I put that in my calculator, I'm going to get c squared is approximately 483.753. But keep that number in your calculator, because what you need to do is square root that number, not this rounded answer, but that number. So you can just press the square root button and you'll have it square root your answer. So I'm going to square root 483.753, but what I'm actually doing is I'm square rooting 725 minus 644 cosine of 68. And then I can round my final answer, which is going to be C is about 21.99 miles. Part B says the federal government is planning on making the area between the two existing roads and the new roads, so this area right here, into a national park. What is the area of the park? Your answer should be correct to the nearest hundredth of a square mile. Well, another formula given to us is area, which is 1/2 AB sine of C. In this case, we know it's going to be 1/2 times A, which is 23 miles, times B, which is 14 miles, times sine of angle C, which is 68 degrees. This is going to be 1/2 times 23 times 14, which is 161, times the sine of 68 degrees. And therefore, my area is approximately 149.28 square miles. Question 63 is a roof is being constructed on a building and slopes differently on the two sides as shown in the figure below. What is the length of the roof represented by BC? Your answer should be correct to the nearest hundredth of a foot. Well, in this case, we're trying to find a missing length, but we're given two angles. We've got one other length. It's not a right triangle, so we can't use our basic trig, Pythagorean's theorem, anything like that. But because we know two angles, we can use the law of sines. So the law of sines is another formula that's given to us. And because I want to find the side opposite angle A, I'm definitely going to use sine of A over length of A. And that's going to be equal to sine of B over B and sine of C over C. However, I need to use the side that I already know, which means I need to use B. So I'm going to use sine of B over length of B. Problem right now is that I don't know this angle, but I do know that there's 180 degrees in a triangle and I'm given two angles. So the measure of angle B is going to be 180 degrees minus 79 degrees minus 43 degrees, which is going to give us a measure of 58 degrees. So when I put this formula to work, I've got sine of 79 degrees, that's angle A, over the length of BC, which is what I'm trying to find, equals sine of angle B, which I now know is 58 degrees, over the side length of 20 feet. I'm going to solve this by cross multiplying because I have a ratio. I have proportions. So I'm going to multiply diagonally, and I'm going to get 20 times the sine of 79 degrees is going to equal BC times sine of 58 degrees. My goal is to get BC by itself, so I need to divide by sine of 58 degrees to get rid of that. And what I do on one side, I do on the other. This shows me that BC equals 20 sine of 79 degrees over sine of 58 degrees. And when I put that in my calculator, I'm going to get BC is approximately, and notice I'm rounding to the nearest hundredth, so it's approximately 23.15 feet. And that is the end of Unit 2, Topic 2, and the end of your semester exam review for Honors Geometry. Good luck on your exam.